Today we're going to talk about angles and how you can draw angles that are bigger than 90 degrees, bigger than 180, how you can have negative angles, what all that means. And we'll also talk about what radians are and how radians and degrees are similar but also different. To begin, a angle in trig class is typically drawn in what we call standard position. Off to the side, you see a picture of an angle that's drawn in standard position. I just want to point out a few things. The initial side of this angle is along the x-axis, and the terminal side of the angle is off in some other direction. And angles are usually measured counterclockwise, starting going through quadrant 1 and then quadrant 2 and wrapping around and so on. And so if I went all the way around, that would be an angle of 360 degrees. And if I continued, now I'm going, what is this, 360 plus 90 more would be 450. Now I've gone around 540 times and so forth, 540 degrees that is. 2 revolutions is 720 degrees, and I could theoretically go on forever. So that's how you could have an angle that's more than 360 degrees, is you just wrap around a few times. Also, you can have angles that are negative if you, instead of going in the counterclockwise direction, if you go backwards, if you go in the clockwise direction, starting off through quadrant 4 and then working your way around and so forth. Now I've just gone 180 degrees backwards, so negative 180 degrees and so forth. So that's a positive and negative rotation. And one skill you'll need to be able to do is to simply take an angle and draw where that, what that angle looks like, specifically figuring out where the terminal side is. So here's a handful of different examples. Let's start with 210 degrees. If I wanted to draw an angle of 210 degrees, I would start off with the terminal side, always along the x-axis. And then I'm going to rotate around in the positive direction. This is 90 degrees. This is 180 degrees. 210 is somewhere between 180 and 270, so somewhere in this third quadrant. And so I'll draw an angle, or a ray in there, the terminal side. And this angle, 180 and about 30 more, that's a 210 degree angle. If we draw in a negative 45 degree angle, I'll do that one in blue. Negative 45, the negative part means instead of going off in the positive direction, I'm going to go backwards, and so I'll start by working my way down, and 45 degrees happens pretty quickly before I get to 90, and so 45 degrees would be here in quadrant 4. And if I drew in a 510 degree angle, that's going to start off with an angle in the positive direction and rotate around in the positive direction, goes up, so 90, 180, down to 270, 360. I still haven't gotten to 510 yet. 360 plus 90 is 450. 450 plus a little bit more gets me into the 500 range. 1.5 times around is 540 degrees, so it's somewhere between here and here. And a lot of times, to indicate more than one rotation, we'll draw the angle like this with a loop. There's 510 degrees. And one thing to note is how close was it to an x-axis or a y-axis? I mentioned that this was 540 degrees, and so when I draw this in, I should try to draw this so that this, what was left to get me to 540, is to scale. That would be 30 degrees, and so yeah, this is about a 30 degree angle. So there's 510 degrees. That puts it firmly in quadrant 2. The follow-up to each of these questions was what quadrant is the terminal side in. For this first one, 210, that ended in quadrant 3. Remember to use Roman numerals for quadrants. Negative 45, that ended here in quadrant 4. And 510 degrees, as I said a second ago, that ended in quadrant 2. This will be really important when we talk about sines of angles and cosines of angles and tangents of angles. What quadrant it is will determine whether those values end up being positive or negative, but that's a lesson for a different day. Now, as soon as you have angles that are more than 360 degrees, you can have this idea, this concept that perhaps an angle might land on top of an older angle. That topic, that idea is called coterminal angles. And let me just draw in an example a second. Suppose I have an angle that goes around once and a little bit more and ends up over here. That is what, 360 plus more, close to 700 something degrees. That's the same as if I had just gone around once and kind of ended almost all the way there, so about 300 degrees. It'd also be the same as if I went backwards a little bit, maybe 60 degrees, or maybe if I went backwards around once and a little bit more, say 420 degrees. All those different angles, they all end at the same spot, and we say that those angles are coterminal. And in fact, I've just answered 3a here a little bit. We've listed a bunch of different angles that are coterminal with negative 60. The green angle is negative 60, and the blue angle that I drew in there, I went backwards around a whole revolution and then 60 more degrees, and so that would be 360 plus 60 was negative 420. And the red angle that I drew in, that was 60 degrees short of a full revolution. So 360 minus 60 is 300 degrees. And the black angle that I drew in originally, that was almost twice around. It was 60 degrees short of twice around. That was, let's see, 720 minus 60 would be 660 degrees. So all of those angles end at the same spot. We say that they're coterminal. And if you want to find other angles that are coterminal with a given angle, it's relatively easy to do. You don't need to draw a picture for it. You can simply add or subtract 360s, and you can find all sorts of different angles. So suppose we started with 495 degrees. If I take 495 and add 360 to it, I get 855. And if I add 360 to that, I get 1,215. And I could keep going. And if I took 495 and I subtracted 360 from it, I get 135. If I subtracted 360 again, I get negative 225. And I could theoretically keep going on that direction as well. Each of these angles is coterminal to 495. And personally, of all of these different angles, the one that I'm most interested in is probably the positive one that's between 0 and 360. In this case, the 135 would be most interesting to me because that's the one that I can see and draw the quickest. 495 would end where 135 ends, and 135 is between 90 and 180, in fact, halfway between. So this is 135 degrees, and 495 degrees would be once around and then ending at that same spot at 135. Now, the last idea we want to talk about today is what is a radian and how does that relate to a degree? A radian is another unit that you could measure angles in. Degrees is what you're probably most used to. Revolutions is another unit that you can measure rotation in. That would be all the way around. A radian is a convenient unit to use specifically in classes like physics, where you are relating and connecting rotation with the amount of distance that something has traveled. And so specifically, 1 radian is the amount of rotation that happens when you move 1 radius along the outside of a circle. As you can see in this picture, if you move 1 radius worth of distance around the outside of the circle, you've rotated a certain amount. That amount is about 57 degrees. It's a little bit less, or a little bit more than that. It's a weird decimal number. It doesn't work out nicely. But we call that amount of rotation 1 radian. And again, it's very useful to connect the amount of rotation that something has undergone with how much distance around the outside of the circle something has gone. So, 1 radian, as I said, is approximately 57 degrees. Again, it's a little bit more than that. We might calculate that exactly in a little bit. And I wanted to draw in what happens if you do another radian. If you go another radius around the outside, you end up somewhere in quadrant 2. If you do another radius outside, which is 1 more radians worth of rotation, you're ending up almost all the way around. And if you go all the way around, that's halfway around the circle, that actually ends up being exactly pi radians, or pi radiuses, 3 point something. And that's a very useful fact to memorize, that halfway around the circle is pi radians, and halfway around the circle is 180 degrees. And that fact, that pi radians is equal to 180 degrees, is one that you should commit to memory. It's one that we're going to use to do some conversions a lot today. So, let's get to it. One of the questions you'll be asked today is to take a given angle and convert it into radians, or if it's given to you in radians, convert it into degrees. And so let's start off with 110 degrees. Let's convert that into radians. So one thing you could do, probably more time consuming than it's worth, but you could draw a picture of 110 degrees and at least get an approximation. 110 degrees is a little bit more than 90. And so just a quick little drawing in here. That looks like about 2 radians, but that's really vague, about. Let's see if we can calculate this exactly. The way I do these conversions is with a conversion train. I'll start with 110 degrees, and I'll multiply it by a conversion factor. The conversion factor is how many degrees there is in a radian, or how many radians there is in a degree. It's that fact that we noticed just a second ago, that halfway around the circle is pi radians, and halfway around the circle is 180 degrees. And so I'm going to multiply this 110 degrees with pi radians divided by 180 degrees. Notice I've got degrees on top and bottom of this fraction, and so the degrees cancels out, and the only unit that's left is radians, and so now my angle will be in radians. And there's 2 different things that are done. Usually in algebra classes, we want exact answers, and this is a fraction, and we could reduce the fraction a little bit. They're both divisible by 10, for instance, and we can leave our answer as a fraction with a pi in it. And so if we do that, we could have 11 pi over 18 radians. And for the purposes of your assignment, that's what you should do, is leave your answer in terms of pi, is what we say. Typically in a science class or something like that, we're more interested in what this number actually is or is close to, and so you'd get out your calculator and type it in, 11 times pi button, or 11 times 3.14 divided by 18, and that is approximately 1.91 radians. And in physics class, that'd be the number we'd be interested in. Question B is just the opposite. I'm giving you an angle in radians and asking you to convert that into degrees. Maybe I wanted to draw a picture of this. I have no idea what pi ninths radians means, and so if I convert that into degrees, it'd be a lot easier to do. And so I'll do the same sort of thing that we did last time. I'm going to start with the given, which is negative pi ninths, and that's in radians. I'm going to put radians purposefully on the top of the fraction. And then I'm going to multiply this by the conversion factor of how many radians there is in a half circle and how many degrees there are in a half circle. That's pi 1/80ths. In this case, though, I need to put the pi, there are pi radians in half a circle. I need to put that on the bottom to cancel out with the radians unit that I have on top already. And there's 180 degrees in a half circle. So the units of radians cancels out in top and bottom. And in fact, the pi value cancels out on top and bottom, and so pi and pi can be reduced, and so I end up with negative 180 degrees divided by 9. Negative 180 divided by 9 works out nicely to 20 degrees, negative 20 degrees, that is. And so now I could draw this angle because I can see what 20 degrees is. I'm pretty comfortable with that. That's going backwards just a little bit. So here is either negative 20 degrees or negative pi ninths degrees. Now, to be honest, if I wanted a picture of this, I didn't have to convert things into degrees. Let me show you a picture and a little tool that you can use to draw a picture of some amount of radians without having to convert it if you want. So I will draw in axis again, and remember pi is all the way around, and if they have, which is extremely common, given you an angle in fractions of pi, I would recommend you break up half of this circle into that many pieces. And so pi ninths, I would want to divide half of this into 9 equal pieces, which is admittedly a little hard to do, but here's 1, 2, 3, 4, 5, 6, 7, 8, 9 equal pieces, roughly. And I need to go one of those in the negative direction, and so here's one of those in the negative direction. That's how you can draw fractions of radians if you want. This is pi ninths. This would be 2 pi ninths and 3 pi ninths, which is the same thing as pi thirds, and so forth. 4 pi ninths, 5 pi ninths, 6 pi ninths, 7 pi ninths, 8 pi ninths, 9 pi ninths, which would be pi again. And all of these are in the negative direction, so they're all opposites, negatives. So Anyway, you might be asked to do that sort of thing, and you might find it useful to do without drawing or without converting things into degrees. So I would encourage you to scan the QR code so that you can see the answers to the other sides. I didn't do any of the even problems here, but you can try them yourself and see how you did. And your assignment's at the bottom. Have a wonderful day, and I'll see you tomorrow.